Hi guys, welcome back to my channel, and in this video I will teach you how to convert a 12 volts to 14 volts alternator into a 120 volts AC generator. Now we all know that an alternator produces DC, but in this video I will convert that DC to AC without using an inverter. So as I told you in my previous video that at the back of an alternator there is a rectifier or a voltage regulator. So what will happen if I will remove that rectifier? Okay, so let's remove it. So guys, this is the three-phase rectifier with a built-in voltage regulator. Okay, so I've removed it. Now all I am left with are 4 terminals from the armature of the alternator: 1, 2, 3 and 4. These 3 are for the star phases, and this is the common neutral, as I told you in my previous video. Now there are other 2 terminals. This is your positive terminal for the brush, and this is your negative terminal for the brush that is going to feed the rotor inside. Okay, so guys, I will be using a 12 volts DC adapter to activate the rotor or the field of this alternator. You see these 2 terminals, the red and the blue. This red and white wire will be connected to these 2 red and blue wires to activate the rotor inside this alternator. Okay, so I will show you the ratings printed on it. Okay, you can see here output 12 volts, 3A meaning 3 amperes, and 36 watts. Okay, 36 watts. Maximum input that I will be giving to this alternator will be around 36 watts. Okay, so let's do it. And guys, I will use this multimeter to measure the generated AC voltage by this alternator. Okay, so we all know that this is a 3-phase alternator, and this multimeter measures only single phase AC. So to measure the overall voltage generated by this alternator, what I will do is I will connect the 2 terminals from the multimeter only to one of the phases of this alternator. It has 3 phases. I will connect it to only 2 wires. Okay, so the connections, if we want a complete power output from an alternator, there has to be 3 load connections: one to these 2 terminals, second to these 2, and the third to these 2. So this way it will be 3 times, but I will be measuring voltage just for one phase, that is 1/3 of the alternator. Although the voltage for all the phases is going to be same, the power is going to be 1/3. Okay, so guys, this is not working. So instead of this adapter, I'm going to use a 12 volts UPS battery. So okay, I will be using this battery. Although it is really discharged, I will show you this. Okay, so okay, I will measure the voltage with a multimeter, the voltage of the battery. So as you can see that the voltage is 12.24 volts. It is showing that it is charged, but as soon as I will connect some load to it, the voltage will fall down to around 6 or 7 volts DC. So guys, I have connected the positive terminal of the rotor brush to the positive terminal of the battery, and the negative terminal still left open. As soon as I will connect it, the electromagnet inside this alternator will get magnetized. Okay, you'll see the spark here indicating that the connection was successful. You see the purple spark? That is because of the inductance from the electromagnet. Okay, so there's no point in connecting it now. First I will wound the thread on the pulley of the alternator, and then I will connect it to measure the overall output AC voltage indicated by the multimeter. Okay, so this is the thread that I am going to use to wound on the pulley of the alternator. Okay, so let me pull it. So you can see that it did not generate any electricity because it does not has any permanent magnet inside it. So we have to activate the electromagnet inside with the help of that battery to get some AC voltage reflected on that multimeter. Okay, so now I will connect it. Yeah, the electromagnet has been activated and now it is really jammed, really jammed. Now I will quickly wound the thread. Okay, and now you should see some AC voltage here. Okay, you saw that it was around 8.6 or 7 volts, 8.7 volts that was generated by this alternator, and it was AC and for the single phase output of the alternator, and it has 3 phases and each phase will have 8.6 volts, but the current will triple if all the phases are utilized with the help of a rectifier that was previously connected. Okay, so guys, now I'm going to use this transformer 12 volts to 120 volts. Okay, so at present it is producing 8.6 volts AC. Now I'm going to step up that AC voltage to 120 volts with the help of this step up transformer. Now how we have to connect this transformer to this alternator is, I will connect it in the single phase form like the way I have connected this multimeter. First I will remove these 2 pins of the multimeter. Okay, and now I will connect the thicker terminals of the alternator that will indicate the primary low voltage high current winding to any of these 3 terminals. Okay, so the first terminal I will connect to this one. Okay, I will connect it like this, it will be easier to see. The second one is going to be this one because it is visible from the camera point of view. Okay, I think the wire is falling a little short, I have to extend it. Okay, now I will use this wire to extend the terminal output, the terminals. Yeah, okay, the second wire will be this one. I can also choose this one but not that one because that is the common single phase. I will use this one because it is visible from the camera point of view, as I said before. So the primary has been connected, the high current. Okay, so now I will connect the meter terminals, these red and black pins, to the high voltage thin winding side. To that place I will connect the terminals of the multimeter to measure the stepped up voltage. Okay, yeah, I will need some pins. Okay, so the positive pin will be connected to the red terminal and the negative will be connected to the blue terminal. Yeah, okay, so the multimeter has been connected to the high voltage side. The low voltage side of the transformer has been connected to one of the 3 phases of the alternator that are coming out from the armature, and the terminals connected to the brushes feeding the electromagnets will be connected to the battery. One terminal is already connected. Now all I have to do is connect this terminal and wound the thread on the pulley of the alternator and it will start working. Okay, so first I will mount the pulley with the thread and then I will connect the second terminal of the battery. Okay, so yeah, I have wound the thread. Now I have to connect on the second terminal. Okay, okay, so watch the meter screen. Go. You saw that it was 88 volts. since the voltage on the battery is really low. Otherwise I would have easily achieved around 120 volts. Although I would like to give it another try, and this time I will pull it a little bit harder. Okay, so I'm ready now. Let's do it. Okay, go. You saw that it was 109 volts AC. Okay, so guys, now I will use this 100 watts 220 volts bulb. Now because the bulb is 220 volts, so it is not going to glow at its full illuminance, since I'm going to use a 120 volts transformer, sorry, 110 volts. Okay, so what I will do is simply connect the terminals of the from the socket of the bulb to the high voltage side of the transformer, and remember that the generated voltage is AC, since there is no rectifier at the back of the alternator. Okay, so the terminals of the bulb have been connected. Now it's time to connect this terminal and wound the thread on the pulley. Okay, so this is complete. 1, 2. Now I will connect this to the battery. Okay, go. So guys, as you saw that it produced 110 volts and it lit up this 100 watts 220 volts bulb. So guys, here as you can see that I've used the same double belt system for the alternator, and the grooves for the belt system on the pulley of the alternator is just great for fitting this belt on the alternator pulley. It creates more friction and removes the slip. And for fixing the alternator to the base, I have used this metal piece on this side, and this claw is stopping the alternator from moving on this side. I have used this metal zip tie for fixing the alternator all over the metal piece from top to below, and one on the back side. I have used another metal piece, and for better positioning of the alternator and fixing the position, I have used this metal wire and I have fixed it to the bicycle. So that's it for fixing the alternator to the base, and there is a really little gap left between the wheel and the alternator, but it is not touching it even when I run it. I will show you. So the alignment is fine. So guys, as you saw that the wheel was not touching the body of the alternator. So guys, you have already seen the video in which I taught you how to excite this alternator with a 3.7 volts battery. If you haven't seen it yet, then you can find the link for that video in the description and in the top comment section. So guys, this is a 3.7 volts 40,000 mAh lithium ion battery pack. These are the two terminals. White one is positive and this uncovered insulation one is the total negative. So I will measure the voltage of this pack for you, pointing the meter towards 20 volts DC mode. Let's keep it over here. At present it is showing 0.01, negative to negative and positive to positive. And as you can see that the voltage is around 3.85, battery is fully charged. Let's connect it to the alternator. So guys, for connecting it to the alternator's rotor or field winding, this green wire that you see is the positive. So the positive of the battery will be connected to the positive of the alternator. So this is the positive. This is the positive of the excitation winding. The main positive of this alternator from which the load can operate is this terminal, the major positive. It is called B positive. Now this is the negative, the uncovered insulation one. It will be connected to anywhere on the body of the alternator because the entire body of the alternator is negative. Since this metal piece is connected to the body of the alternator, so I'm going to connect this terminal on this part with the help of this clip. There is a little spark indicating that the rotor has been excited. So let's connect the multimeter to the output terminals of this alternator and then excite it while drain the battery. So guys, the display of the multimeter will be set at 20 volts DC mode since the output from the alternator is going to be DC because of the 3-phase rectifier, and the red will be connected to the main red output positive, which is this one, the positive B terminal that I told you. Yeah, this is the better way. Positive has been connected and the negative will be connected to this part, okay, or this part. Negative has been connected for the multimeter. Now comes the negative for the battery. Okay, so guys, the rotor winding has been excited. The meter is showing 0 volts. Now let's start the bike and see what voltage I am getting over here after running the bike. Yeah. So guys, there is one situation that I am facing. After this alternator generates 4 volts, it becomes really hard to run it. Maybe it's because the voltage that this alternator is generating after 4 volts, it is feeding the battery and recharging it. And this battery cannot go beyond 4 volts because it's a high capacity battery and it is rated for 3.7 volts. So what I'm going to do, I'm going to remove this battery and replace it with a 12 volts UPS battery just for safety purpose and see what happens. So yeah, I've removed the 3.7 volts battery pack, and instead of that I'm going to use this old 12 volt 7H UPS battery. For terminal connection, I'm going to use this blue and yellow cable. Blue is for positive. I always take blue for positive and yellow is for negative. Okay, blue is for positive, so positive will go to the green terminal. Okay, now with that being done, the negative will go to the body of the alternator. So this is the body. You see the spark? This means the rotor is getting excited. The excitation will obviously be more because the battery voltage is more, so the excitation is also more. Let's see if it is displaying some voltage on the multimeter. No voltage display, but anyways, let's do it and see what happens. Okay, the final yellow terminal, which is the negative, will be connected to the body of the alternator. So yeah, the battery has been connected to the body of the alternator. Now keep watching the display screen. I'm going to run the bike. Yeah, it is still really tight. Now guys, I did a lot of research on this alternator, but I didn't find much about this alternator on the internet. So I experimented and I found that this alternator was the best kind of alternator that I ever had. Among all the collection of alternators that I had, this is the best one. It is a self-excited alternator. So guys, you see here I have removed all the batteries. This is the 40,000 mAh battery pack. This is the 12 volts 7 ampere hour 7Ah, and this is a car indicator bulb. So guys, here I'm going to show you the coolest thing ever. You see, this multimeter is pointing towards 20 volts DC mode, okay? Keeping it here, at present it is displaying 0 volts. Negative has already been connected over here, as I already showed you. You see here, no other wire is given. Negative has already been connected, positive is left out. So I will place this positive over here as I did before and connect this terminal over here. Okay, so nothing has been connected to the rotor or field winding of this alternator. This green wire is completely disconnected, which feeds the brushes. And now you just keep on watching the display screen of this multimeter, okay? And I'm going to run this bike. So guys, you saw that it generated around 1 volt without any battery excitation. So when I was testing it initially, then I thought that it is generating 1 volt without any battery. So a diode has a forward bias voltage of 0.7 volts. So if we remove that, then we get around 0.3 volts. That should be enough to excite the rotor. And because it is generating 1 volt without any battery, that means that some magnetism is left in the rotor of field winding of this alternator, that is circulating current through the armature winding, and it is coming out and being displayed over here on the multimeter display screen. So then I thought, why not feed that 1 volt generated voltage to the rotor winding without any battery? It might get self-excited. So I simply connected this green wire to the positive terminal, okay? And in my initial previous video, I told you that the body of the alternator is negative, which is connected also to the negative terminal of the brush. So positive is connected to the main positive output of the alternator, and negative of the brush is already connected to the negative of the alternator. Now you see what happens on the multimeter screen when I run the bike. So guys, you saw that initially when I was running it at low RPM, it was not getting excited because the voltage generated by the armature was around 0.7 or 0.6 volts, which was not enough to excite the rotor winding. But when I increased the speed, the forward bias voltage of the diode crossed the threshold 0.7 volts and it excited the rotor, and automatically the more and more voltage and current start flowing through the armature winding, and it became really hard because all the current that was being generated in the armature winding was being fed to the rotor winding for excitation. So more current was flowing through the rotor winding, which was not needed. So then I decided to place a resistive load in between the rotor winding and the armature winding to get more voltage at the output at lesser input of the RPM from the bike. So for that I used the car indicator bulb that I'm just going to show you now. Now guys, this is a 12 volts car indicator bulb. You see, it takes around 2 amperes to glow. So what I'm going to do is remove this clip, connect one of the bulb wire to this green terminal and the other to this clip positive, just for limiting the current that is flowing through the rotor of field winding. And then you see what happens to the display, okay? So guys, you saw that at such a low RPM it was generating around 15 to 16 volts. That was really good, and the bulb was glowing. It is hot now, yeah. And the bulb was glowing not because of the generated voltage from the armature that is coming out directly, but flowing first through the rotor winding and then getting on through this bulb. This bulb is nothing but just a resistive load. The actual output will be this as positive, to which the bulb is connected, and the main body of the alternator, that is the main negative. So guys, now you can see that I have also removed the bulb here, and in place of that I have connected this thin wire as the resistive load. Yeah, you see here, I've connected that to excite the rotor winding. Now first I'm going to show you the current that is being generated. I haven't tested it yet myself, and after that, if this multimeter survives, I'm going to measure the voltage. Okay, so guys, let's start the test now. Now guys, the current generated as shown on the multimeter was really less. It was only 1 amperes because the rotor wasn't excited too much. Now comes the voltage that I'm able to generate over here. So guys, as you saw that the voltage went beyond 20 volts. Let's point it towards 200 volts and then start the test again. So guys, as you saw that it generated around 20 volts DC at without any problem. Yeah, it generated around 20 volts DC and the current was around 0.85 amperes. Now to increase the current, we will have to reduce the resistance that we have added to increase the current flow through the rotor or field winding. So for that, what I'm going to do is fold the coil like this. So this part of the resistor is bypassed. Okay, now let's check the current generated over here. At present, 0 amperes. I'm pretty sure that the multimeter got damaged because it went beyond 10 amperes, much beyond 10 amperes. That was a little bit expected of it. Yeah, this is heating. Yeah, actually the alternator is capable of reducing up to 90 amperes. Reducing the resistance increases the rotor current flow. That in turns increases the current output of the alternator. So managing the resistance between the rotor and the armature, with that we can get the required voltage and current at the required RPM according to our needs. That's the best part of the alternator. I'm going to do the test once again to make sure if the alternator is working or not. Yeah, without much problem, you saw that it generated around 14 to 20 amperes. The alternator is still working, but the fuse might get damaged. So as soon as I see it displaying 14 amperes or 15 amperes, I reduce my cycling speed. So this alternator is really good. It is generating more than 10 amperes with this bicycle generator, and with this resistance being added between the rotor and the armature, we can manage the output current and voltage. Hi guys, in this video I'm going to teach you how to convert this 12 volts 120 amps car alternator into a high speed, high torque DC motor that runs on a 12 volts battery. Now guys, as you can see that I have opened up this alternator. This is the base bearing holder with the brushes installed in it, and this is the one that houses the armature winding. Now you can see this is a very old alternator, and the armature winding is all blackened, and you can also see some ruptured insulation points on this armature winding. So I also have to take care of that. Now guys, these 4 output wires are from the star connected armature winding, which were initially designed to charge the car batteries with the regulator and the rectifier in between. And now the reverse is going to happen, meaning the batteries are going to charge these windings. with the controller in between. And guys, you can see this is the bearing which was really jammed initially, but I have oiled it up and now it is working as good as new. So guys, out of these 4 wires, there is one wire with 4 tappings. So we have to remove that wire because that is the center of the star connected winding and it is not needed when we are using this alternator in the motoring mode. So guys, I think yeah, this one is the tapping point. So the blue wires coming out from the controller will not be connected to this point and it will be connected to the other 3 wires. And there is only one tapping point in a star connected winding. Now guys, you might have seen my previous video which is completely related to this video since that was the part 1 video and this is the part 2 video. There were 4 major drawbacks seen in that video when compared to this video. Firstly, the rotor was completely jammed. It was very difficult to rotate the rotor with hands. Secondly, there were a lot of controller heating issues. Thirdly, although the alternator was running, it was not running at a very good speed. And lastly, it was making a lot of sound while running, which was another major drawback. So guys, I'm planning on removing all those drawbacks in this video. So here as you can see, I am covering the armature winding with this insulation tape to prevent any further insulation rupturing of the armature winding. Also guys, if you want to watch the previous part of this video, link has been provided in the description along with the purchase link of the controller that I will use in this video as the video follows. So guys, this is the controller that I will be using to power up the alternator to run it at high speed and with high torque. And you can see guys, the wires coming out from the controller, the blue ones. Here I am connecting them to the pinouts from the three-phase winding of the armature of this alternator. And remember that we have to leave out the neutral point of the star connected armature winding. Okay, now let's place the alternator and the controller best according to the camera point of view. Yeah, this seems fine. Okay, now the closer view. Here you can see one of the pinouts has been left open and the remaining have been connected. And you can also see red and blue wire feeding the rotor winding or the field winding of this alternator. They are to be extended with this yellow and white wire. Yeah. Okay, so guys, the white and the yellow wires have been connected for extension, and these two wires will be connected to a 12 volts battery for powering up the rotor winding, which will create magnetism inside the alternator. Here I'm also going to use this 15 volts 3 amperes laptop charger that is going to power up the controller. And guys, I used the same laptop charger in my previous video for running this alternator. Also make sure that you connect positive to the positive and a negative to the negative. That is really important. Now this is the closer view and you can see that red has been defined as VCC and black as ground. At present the charger is not connected to the power supply cord. Now guys, here I'm going to use this 12 volts bike battery for powering up the rotor winding to create magnetism inside the alternator. Let's measure its voltage. Here it is showing 11.67 volts, means it can be used. Now let's connect the cord to the laptop charger. Now all that is left is connecting the rotor winding to the battery. Now guys, with that being done, let's get started. So guys, it's clearly visible that the performance is much better than it was in the previous video. The noise level has reduced, the starting torque has increased, and also the running speed is very good. Now the closer view. Also guys, there is no controller heating issue anymore, and the controller is working like charm. So it's time to proceed to the next phase, in which I am replacing the laptop charger with this 12 volts 7Ah UPS battery to feed even higher current to the controller. And let's see the performance then. And yes, in place of the battery 12 volts bike battery, I'm going to use the laptop charger to power up the rotor winding. So guys, the rotor or field winding has been excited and the battery has also been connected to the alternator. It's time to turn the knob. So guys, as you saw that the speed was very high, and here as you can see I'm touching the circuit to make sure that the circuit is not getting heated up, and it is not heating at all. Now guys, as you can see I have completely removed the laptop charger, and in place of that I am using battery to power up both the rotor winding and the armature winding. Let's measure the performance now. So guys, this is the maximum performance I achieved for both speed and torque. I believe that is because I fed pure DC to both the rotor and the armature. Now guys, let's do the clockwise and anti-clockwise direction test. At present, it is running in the clockwise direction. Let's change its direction to anti-clockwise. Okay, start. So guys, that would be all about today's video. Thank you so much for watching it. Please hit like and don't forget to share and subscribe. And if you have any queries, you can always ask them in comments. Thank you.